Okay, the absolutely last K we're going to talk about this year is KSP. And KSP is the solubility product, that's what the SP stands for, solubility product constant for salts. And these problems look a little bit different. They start out as usually a solid, and then the solid breaks apart into its ions. And we just try to calculate the numbers for those particles. So remember, dissociation means that it breaks apart. There are two things to remember about this. If you have a base salt like OH minus, this will break down completely, meaning it will lose all of its OH minus at once. So here's an example of what the dissociation of calcium hydroxide would look like. You would break it apart, so you'd have calcium plus 2, and then 2 OH minuses, all right? And we did this a little bit before in the past, but the next one you'll see what we definitely did was if you have an acid, it only loses the H plus one at a time, as we did in the last chapter. So H2SO4, ooh, bad example because that's a strong acid. Let's say it's H2SO3, then it's an equilibrium problem. H2SO3, it will lose one of those H's at a time, so you'll end up with this here. Notice that the difference is you still have an H attached to this, where in this one they all just completely broke apart. All right, so that's kind of the difference between acids and bases when we see this. All right, is everybody cool with that? That's just that reminder. Now, obviously, it's a reminder here, like, hey, this is going to show up in some problems. Okay, back to the problem. So, calcium fluoride dissociation. Given the KSP equals this, create an ice chart, create a KSP equation, solve for X, and then use X to solve for the concentration of calcium and fluoride. So this looks a little complicated, so let's just go through the beginning parts of it right now. We're just going to do the ice chart, and then maybe we'll do the K chart as well. So ice chart for this. And they didn't give you anything, so I'm gonna have to, this is how we would write it from scratch. You just write whatever it is, calcium fluoride, and then dissociates into calcium plus 2, and then 2 of the fluorides. These are aqueous. Now you can see this relies on a lot of our knowledge of prior chapters, okay? I had to know what the charge of calcium was. I had to know that the charge of fluoride is this. I had to make sure that it all balances out, everything looks good. Make our ice chart. Did they give us an initial concentration for this? Calcium fluoride? No. They also, it's a solid, right? So you actually put an X through it and you have nothing for that, which is pretty interesting because it all dissociates. They didn't give us an initial concentration. It's a solid. We said you can't use solids with ice charts. So there's nothing to really do for this one, which is pretty great. That means these problems are going to be a little easier. We also know how much calcium and how much fluoride do we start out with. This doesn't change. It's still always going to be 0. And now we have to do the change. So is it going to be a plus or a minus, first of all? We're talking about the products here.
Plus.
Yep, it's always plus for the products. Is the calcium going to be an X, X2, X3, X4? Just an X, because there's only one of them. What about the 2F here? It's going to be plus what? 2X. Awesome. And for equilibrium, it's 0 plus what we just did, so you just bring them down again. So we get those in there. All right, everybody's cool with that? Basically, same idea for the ice chart. The only thing that you're looking for now is if it's a solid, you just cross out the whole thing. All right. And now we need to set up that KSP equation, which is very similar to a K equation. All right, so KSP equals, we don't use the solid, so it's just going to be Ca plus 2, and then F minus to the second squared. And then we just plug in what we have for numbers. Do we know KSP? Yeah, they gave it to us. KSP is 4.0 times 10 to the negative 11. Do we know what calcium? That's going to be an X. Do we know what fluoride is? 2X squared. We do have to simplify it. So 2x, the quantity squared, becomes what we saw before. It's going to be 4x squared. So we have 4x squared, and then there's another x in there. So if we want to multiply another x in there, what are we going to get? Yeah, it's going to be 4x cubed. So this is going to be 4.0 times 10 to the negative 11 equals 4x cubed. And that's as far as we're going to get today. All right, we'll take it from there tomorrow. Actually, I don't see you guys tomorrow. We'll take it from there on Thursday.